Hello students, this is Miss Dalton. This is video 8.3, Polynomial Real Zeros. Finding rational zeros. You need to remember that a zero is also called a root or a solution of a function, so we use those words interchangeably. So make sure you remember that those all mean the same thing. The possible rational zeros of a function can be found by dividing the factors of the constant by the factors of the leading coefficient. This is going to look like, we oftentimes say this is P, we oftentimes say that this is take the factors of P divided by the factors of Q, and what that means is, like, you might have, Q x squared minus x plus P. So this is the constant. So you're going to take all the factors of that constant and divide them by all the factors of your leading coefficient. So you'll see what that looks like in just a minute. You can use synthetic division with each of the possible zeros to determine which are actual zeros. The remainder must be zero in order for it to be an actual zero. Keep that in mind. Okay, so that was for just all rational zeros, but this is how you can find real zeros, which are real numbers. The first thing you want to do is you want to try and factor if possible, and then if you can factor, set those factors equal to 0 so that you can solve it. If it doesn't factor, the way we're going to do this in class is you need to go ahead and graph the function on your graphing calculator. You're going to choose one zero that's either from the graph or a table and use synthetic division to prove it is a zero, and then use your quotient from the first division to find the other zeros. Remember, not all rational solutions are whole numbers. Okay, so in this first example, it says list all possible rational zeros of the function, and our polynomial is 2x to the third plus 7x squared minus 4x plus 8. So what you're going to do is you're going to take that constant and the leading coefficient. Now you're going to write down all the factors of your constant first. So let's write down all of the factors of 8. So I usually just start at the beginning. So 1 and 8. Now I'm going to put 8 down here because I want to list them in order. Then I'm going to go to my next number, 2. Well, that would be 2 and 4. And then after 2 would be 3, but 3 does not go into 8. And then I'd be back at 4, and I've already got 4 listed down. Then you want to look at your factors of 2. Well, my factors of 2 are just 1 and 2. And then to list all of your possible the possible zeros, what you're going to do is you're going to take each of these and divide it by each of these. So what it's going to look like is you're going to have 1 divided by 1, which is just 1. And we're going to put plus or minus 1 because that could be negative 1 as well, because we didn't take the signs into consideration here. So you just want to keep in mind that it's always going to be the plus or minus of what these factors are. Then you can also do 2 divided by 1, which would just be 2. Then you'd want to do 4 divided by 1, which would just be plus or minus 4. And then you'd want to do 8 divided by 1. So that would be plus or minus 8. Then you also have to do all of those red numbers divided by the 2 that's green. So you'd want to do 1 divided by 2. So that's going to be a plus or minus 1/2. And then you can also do 2 divided by 2, but 2 divided by 2 is 1, and we already have it listed. Then you'd want to do 4 divided by 2, which is 2, and we already have it listed. And 8 divided by 2, which is 4, and that's already listed. So that's all of your possible rational zeros that you could have for this polynomial. Example 2 says to find all the zeros of this polynomial. So you'd want to take the constant and get all of the factors of 24. So let's see. We would have 1 and 24. We would have 2 and 12. We would have 3 and 8. Running out of room, but we would also have 4 and 6. And then our leading coefficient is 1. Well, the only factors of that would just be 1. So it's basically going to be all of these that we need to check, because those divided by 1 would just be those numbers. Okay, so I usually start at the beginning. What you're going to want to do is you're going to want to use synthetic division to see if it is a factor. So let's try 1. We're going to use our coefficients. So 1, negative 12, 35, and negative 24. So bring down your 1. This would be 1. This would be negative 11, which would be 24, which would be positive 24. So we got lucky. That first one is a factor. So our first, well, since they want zeros, I guess I don't need to write down the factors. So our first factor is 1. Then what you'd want to do is you could see if you can go ahead and factor what's left. So what would be left here is x squared minus 11x plus 24. And I recognize that that factors as x minus 8 times x minus 3, which after I set those equal to 0, then my x will be 8 and 3. So my other factors are positive 3 and positive 8. So that's all the zeros for this polynomial. Again, when you're working through this, you just have to find one and start, like find out the possible number of zeros that you have, and then just pick one and start with it and try and get that remainder to be 0. If the remainder's not 0, then you need to try another one. We just lucked out on that first time getting it to work. Something that I will do is when I have a possible list, I always start with the lowest values and work my way up. So keep that in mind. Okay, example 3. Given that you have zeros of negative 2 and 1.5, find all the other real zeros of this polynomial. So we're kind of lucky in the sense that they give us some zeros to start with. So they do tell us that negative 2 is a 0. So let's go ahead and put our, let's use synthetic division. So we've got 2, 5, negative 18, negative 19, and 42. Now we should get a remainder of 0 because they've told us that this is a 0. So we're going to bring this down. That gives us negative 4, which is 1, negative 2, which is negative 20, and that gives us positive 40, which gives us 21, which gives us negative 42, and that does give us a remainder of 0. Now we can do it again with the 1.5. So change colors. So let's put 1.5 on the outside. And let's do it again with that. So bring down your 2. 2 times 1.5 is 3. Then that gives us 4. 4 times 1.5 gives us 6. Negative 14. Negative 14 times 1.5 is negative 21. So there we see that we do get that remainder of 0. Now what this does is this breaks down our polynomial. So now what we have, this would have been x to the third, And so this would be x squared plus 4x minus 14. At this point, you want to go ahead and try and factor that because that's going to give us our other zeros. So let's go ahead and write down our parentheses. 2x squared, that's got to be 2x and x. Negative 14, we've got to get it in here. We've got to get factors of negative 14 that when we do the outside and the inside, it adds up to 4. So let's see. Okay, well this doesn't actually factor. So what you would have to do is you'd have to use the quadratic formula. So the quadratic formula says do the opposite of b, which is negative 4, plus or minus the square root. B squared would be 16 minus 4 times 2 times c. And it would be all over 2 times a, which is 4. So go ahead and simplify that. That would be negative 4 plus or minus square root of 128 all over 4. I had to get my calculator out to do that real quick. Then you go ahead and simplify the radical. So we have negative 4 plus or minus, let's see, I know 16, I think 16 goes into that. All right, sorry, I paused that because my clock was going off, but that comes out to be 8 radical 2. If you can see, I went ahead and broke it down over here on the right, and that's over 4. So we've got that magic triangle that we can divide out of. So our final answer would be negative 1 plus or minus 2 square root 2. And that's going to be our other 2 zeros. Okay, last example, example 4. It says find all real zeros of this polynomial. This is a pretty large polynomial that you would have to do p divided by q on because you've got 96 as your constant. That has a ton of factors, and then you'd have to divide all those factors by 3. So if you would, just go ahead and take your graphing calculator. If you don't have a graphing calculator at home, you can go to Desmos and go ahead and type in this polynomial. And I want you to find the zeros. So again, that's where it crosses the x-axis. Find the zeros. You're going to find 2 of them. One of them is negative 4, and one of them is 2. Now what I want you to do is I want you to prove that those are zeros. So we're going to use synthetic division. We're going to go ahead and put in our coefficients. So 3, 6, negative 12, 24, and negative 96. Now I already looked to make sure that I wasn't missing any terms, and I'm not. But remember, you need to do that every time you do this. So I'm going to bring this down 3. So that gives me negative 12, which gives me negative 6. Which gives me positive 24, which gives me 12, negative 48, negative 24, and there that gives me positive 96. So you can see that that is a 0. And then what I want you to do is I want you to do it again with 2. So we're going to bring down the 3, 6, which gives us 0, which gives us 0, which gives us 12, which gives us 24, and there, in fact, we do have another 0. And so this is our leftover polynomial, which this would have been x to the 3rd. So now this is x squared. So we're going to have 3x squared plus 12. And we want to try and go ahead and factor that if you can. So that's going to be 3x, well, set it equal to 0 and solve it from there. 3x squared is equal to negative 12. X squared is equal to negative 4. So if I take the square root of that, that's going that's going to give you an imaginary solution. So you're going to have x equals, that's going to be plus or minus 2i. Since they're wanting to know the real zeros, imaginary numbers are not real numbers, and so the only real zeros are going to be that -4 and 2. But again, I do want you to verify that by using synthetic division to show that remainder of 0. All right, that's it for today's video. Please make sure that you have your questions written down so that we can address those in class.